Okay, so today I'm going to give a demo about the project we have done. That is what's cooking on Kaggle. We have worked on a Kaggle competition for text mining. So first, let's take a look at our data set. Yeah, so this is our data. So this is the training file, and this is the test data file. So the train data file consists of ID, cuisine, and the ingredients of the recipe. So we have this large file of training data set. And then coming on to the test data. So this test data consists of ID and the ingredients. And you can see that the cuisines label is missing over here. So that is the one we have to predict. That is our task to predict which for given a set of ingredients, what cuisine it belongs to. Okay, so now let's take a look at the exploratory data analysis and models we have built to perform this. Yeah. So now coming to the exploratory data analysis, uh, we have done this on the training data set. We have imported the training data train.json. We have converted it to the normal pandas data frame. Yeah. So the first plot shows the uh, frequency of appearances of a particular cuisine. So we have shown it in the form of percentages. So we can see here that Italian has about 19 occupies upon around 19% of the training data set. Coming to the Mexican, then Southern US, then Indian, and the list goes on. Then coming to the second point, that is the most popular ingredients. So the most popular ingredients can be seen in this graph, where we can see that salt is almost present in all the cuisines. It is above every other ingredient, and we can see that the bar drops significantly lower. That is more than 50%. Uh, coming to the second and coming to the second most used ingredients, there is a tie between onions and olive. We can see from this, and the list goes on. The number of ingredients no, and the count goes on decreasing gradually. Now coming to the third graph. This graph shows us the maximum number of ingredients per cuisine. So here again, Italian ranks the first. It has highest number of ingredients, around 67. Then comes the Brazilian, and we can see that Russian has the lowest number of ingredients, that is around 27 to 30. Then coming on to the fourth graph. So this graph shows, it is similar to the above one. This graph shows the number of ingredients, average number of ingredients per cuisine. So we can see that all the cuisines can be made with about 9 to 13 number of ingredients, which is not a large variation, but still we can see that Moroccan has the highest number of average ingredients. Then we try to analyze the top 10 ingredients of all the cuisines. So we can also see here that rank one is almost everywhere is salt. So we can conclude that our first graph was quite correct and accurate according to this one. So the this could be helpful to any of the users. They can take a look and see for a particular cuisine what are the top 10 ingredients needed. Then coming to the next one, let me share it. Yeah. So coming out to the first model, that is logistic regression. So we performed logistic regression on the data set. We converted the JSON to pandas data frame, like we did in the first part. Then we perform some label encoding. Uh, then we trained the data on with the logistic regression model, and we got a score of about 0.783. And we noted the predictions and converted it to a CSV file, which can be later on uploaded to the Kaggle website to check our score. So now let's take a look at the other models. Yeah. So in this part, we will take a look at the decision tree model and a random forest model, and see how they work and what we have done in the data pre-processing part. We converted the JSON to pandas data frame. Then we did some label encoding, and we passed the data on to the TF-IDF vectorizer, so we can get good clean data. Then we implemented the random forest model with about 100 estimators, which will create around 100 trees, and the each tree will learn from its previous mistakes and give us the best possible value. So we predicted our values over here on the test data set, and we converted it to a CSV file, which I will show in the upcoming part. Then we also, in the similar fashion, we implemented the decision tree classifier. We predicted it on the test data set, and then we converted the predictions to a CSV, which can be uploaded to the Kaggle. Okay, now let's take a look at our last model. Yeah. So we have implemented a one versus rest classifier using SVM. In this model, we converted this is the regular part. We converted it to our pandas data frame. Then we used WordNet lemmatizer to lemmatize our data. So here are a few of the examples, like eggs get converted to egg, and all of the all of the words and letters are converted to lowercase. Then the percent sign and on data or the symbols which are not useful are removed, like and. Then coming on to the next part. Uh, yeah, we implemented the label encoder over here. So we got the following output. Then we let me come on to the model part. Yeah. So here we implemented the TF-IDF vectorizer. Then we passed it on to the one versus rest classifier model. We fit it for the predictions, and then we converted it to a CSV file, and we got the best results for one versus rest classifier, which I will be showing by uploading it to the Kaggle website now. Yeah, so this was our computation, and this is the overview of it. So now let's submit our CSV file and check out what score we get. Yeah, coming on to the text. Yeah, so these are the submission files which I have downloaded already. So we will first upload the random forest one. Yeah, and then make a submission. So here we can see that we get a score of 0.78 to 218 for a random forest submission or random forest model. Now let's take a look at our one versus rest classifier. Yeah. So here we can see that it gives a score of 0.8201, which is quite good score as we compare to other scores uploaded in the competition. So the best score is around 0.84. We got quite close to it, but due to time constraints, we could not evaluate other models, which can be done in the future work. So that's it. Thank you.